For the final section in Chapter 5, we have 5.6, which are the half-angle identities. They're the bad ones because they involve square roots. There is one half-angle identity for cosine, one half-angle identity for sine, and 3 for tangent of half of an angle. Notice that in each of these, the left angle is half of the right angle, whereas in the double angle identities, the left angle is double the right angle. Does that make sense?
Yes.
Okay. So they're very, very similar. We have cosine of half an angle always equals plus or minus, and you will choose the plus or minus depending on the quadrants. The square root of 1 plus cosine of the whole angle divided by 2. Sine of half an angle always equals plus or minus the square root of 1 minus cosine of the whole angle, all divided by 2. Tangent can equal one of these three things. I'm not going to read them out loud. I'm just going to let you study them for a minute and take some notes on them. Notice, though, that tangent's last two options, here and here, they don't involve square roots, but they do involve you being able to find both sine and cosine of the whole angle. So, that's a trade-off. The square root, but you only need cosine of A. If you don't have the square root, you have to have sine and cosine of A. So just kind of depending on what your situation is, you'll choose between those. So I'm going to pause right here, let you take some notes. Okay, so these are the 5 new identities for today's lesson. Make sure that you're familiar enough with them to use them, but you do not have to necessarily memorize these. They will be provided for you. Are you ready? Okay. Let's take a look at example 1. We would like to find the exact value of the cosine of 15 degrees using the half angle identity for cosine. I'd like to point out that we've actually found the value of cosine of 15 degrees before using the difference identity, cosine of A minus B, and we used either 60 minus 45 or 45 minus 30. So this is one of those sections on your test where you're going to have to read the directions very, very carefully. So if I say use half angles, use them. If I don't specify, it's probably easier to use sum and difference if it's not specified. Okay, so if we want to find the cosine of 15 degrees, that's not on my unit circle, and we want to use a half angle. Cosine of 15 degrees, there's only one half angle identity that goes with cosine, and it's that cosine of half an angle always equals plus or minus the big square root of 1 plus cosine of the whole angle all over 2. 15 degrees would go on the left or right side of that.
The left.
Why? You're right.
It's a half an angle.
Half of what?
30.
Good. It's half of 30. So it wouldn't make sense to put it on the right because then the left side would be 7.5 degrees. You want to put it in the spot that will allow the other one to be on your unit circle. So we are going to put 15 degrees over here. And we know that 15 degrees is really half of 30. Does that make sense, you guys? So that equals plus or minus the square root of 1 plus the cosine of 30 all over 2. So I'm going to pause for just a second and let you think about it and see if you have any questions. Okay, so what we have is cosine of 15 degrees equals plus or minus. Guys, where's 15 degrees? It's in quadrant 1. So we know that it's positive square root of 1 plus whatever the cosine of 30 is. What is the cosine of 30? Square root of 3 over 2 all over 2. Now that square root is over all 3 of those things. So technically, the trig is done. Now we just have to use algebra to clean it up. The first thing you have to do is clear those fractions. So I recommend, and you are allowed to multiply under a square root. Go under the square root and multiply everybody through by 2. So this will become 2, this will become 2, and we'll multiply that by 2. So here's what we have now. We have the square root of 2 plus the square root of 3 all over 4. Now the problem is we have a fraction that has a square root denominator. So what you do is you split them apart, leave the top square root of 2 plus the square root of 3 all over the square root of 4. And then you simplify the bottom, which becomes a whole 2. Guess how we get rid of the double square root?
Square.
Well, we can't. We can only do that if we have two sides of an equation.
Oh.
Guess how we get rid of it? You don't. For some reason, that doesn't bother mathematicians. Square roots and the denominators do, but a square root over a square root, we have no problem with it at all. You just stop there. Yeah, so that's your answer, you guys.
Don't you have to simplify it?
No, it's part of a binomial. And one's under a square root, so it's two reasons you can't. All right, right now, I want you to look back to the section where we did cosine of 15 degrees in 5.3, and I want you to find the answer that we got there. Find it for me. I'm going to pause. So when we worked this problem with the sum and difference identities, we got cosine of 15 degrees. We used, what, 45 minus 30? Okay, 45 minus 30. And we got square root of, somebody read it to me, square root of
6 plus square root of 2 over 4.
all over 4. Okay? These two things should be equal. Type them in your calculator and see if they are. So when we typed all of those into our calculator, we got 0.965. Hey guys, 0.965.
925.
Okay. And see, we got that if we typed this, or if we typed this, or if we just typed the cosine of 15 degrees. So the nice thing is, if it's numerical, you can check it. But you will, depending on which way you work, it will look like you got two different answers, but they are really equivalent. For our next example, we're going to find the exact value of the tangent of 22.5 degrees using the identity tangent of a over 2 equals sine of a over 1 plus cosine of a. So since it's a tangent, we actually have three options, but they told us which one to use. So we'll do that. First, we need to substitute in. Does 22.5 go on the left or the right? The left, because it is half of what? So the right angles should be 45s. Okay. Then we simply substitute in what we know from our unit circle. The sine of 45 degrees is the square root of 2 over 2. And the cosine of 45 degrees is the square root of 2 over 2. And if you learn nothing else this unit, at least you will know how to simplify a complex fraction. Your Algebra 2 teachers will be so proud. So what do? I multiply top and bottom through by 2. So multiply by 2, multiply by 2, multiply by 2. And that equals square root of 2 over 2 plus
Square root of 2.
oh, that's no fun. What do I have to do now?
Multiply.
I have to rationalize the denominator by multiplying the top and bottom by the conjugate of the denominator, which in this case is right, so we distribute the top and the bottom. And now we have 2 square root of 2 minus 2. That's a lot of 2's. All over first, outer, inner, last. 2 minus 2 square root of 2 plus 2 square root of 2 minus what? Uh-oh. Hey, I can't multiply. What should this be? A 4. Let's step back. Did that work? Yes? What happens to these two guys right here? They do. They cancel to 0. So it looks like we have 2 square roots of 2 minus 2 all over 2. Oh, goodness.
Oh, we can simplify.
We can simplify that by taking a 2 out of the top.
Square root of 2 minus 1.
And it reduces to the square root of 2 minus 1. How do we check it?
Put it in the calculator.
We can type it in our calculator. We can type tangent of 22.5 degrees. And then we can type square root of 2 minus 1. And we can make sure they equal each other. And if they don't, we should start over and try again until we're successful. Agreed? Great. There's a nice place to break.
Yeah, they equal.